Hello, welcome to Skill 5.1, which is on logarithms. So logarithms are just basically another way to write exponential functions, and they're actually used to solve exponential functions, as we'll kind of see at the end of this unit. And the way that we write logarithms is kind of related to the way that we write exponential functions. So our b kind of represents the base. The a is the exponent. And then the n would be like the number, so to speak. So let's say we want to find log base 8 of 512. And we want to know what the exponent is going to be. So we would write 8 to the a equals to 512. So essentially what we're asking here is 8 to what power is equal to 512. And it turns out that if we are to answer this question, we would say that it would be 8 to the third. So we could say 8 to the a equals to 8 to the third. So therefore, a is equal to 3. And you could actually also use your calculator too. So there's a log button on your calculator. And we'll actually learn some calculator tricks for where you could do that as well. So let's take a look at some basic problems here. So on Delta Math, we have log base 8 of 64. So for these basic ones, I like to just set them equal to x. So this is saying 8 to the x. And I like to put little arrows here to kind of help me write that in exponential form. So basically I'm asking 8 to what power? It's 64. And the answer to that is 2. And I'm showing just a few more steps than what you need. I would say if you're kind of going and you're getting into the rhythm of logarithms, you could actually immediately say 2, almost mentally, and that's fine. But I just want to show you where this is coming from. And then why don't we just take a look at one more? I often find that people who kind of struggle at first with these typically do better when they look at a few examples and then look for patterns. So like the log base 8 of 64, we're going to write this as 5 to the x equals to 125. And then my goal is going to be saying 5 to what power equals to 125. And 125 is basically 5 to the third, making x equal to 3. Let's take a look at some other ones as well. For the level 2s, There are a few things that we put in there to make things more interesting. If there is no base, we can assume that it's base 10. Actually, logarithms relate to base number systems. We have a base 10 number system. So what that means is that with every 10 numbers, we add another digit. So when we get to 10, we add another digit. When we get to 100, which is 10 tens, we add another digit. When they started programming computers early on, they used binary. So they just had zeros and ones. So that's base 2. So we kind of default to the base 10 number system. And this basically just says 10 to the x equals to 1. And we know that any number to the 0 is equal to 1. So we're just going to say that x is equal to 0. Sometimes we have a situation where we have negative exponents. So we might want to say for this that we have 7 to the x equals to 1 over 49. And the 1 over 49 kind of translates into 1 over 7 squared. So this would be 7 to the x equals to 7 to the negative 2, making x equal to negative 2. And then I would say the worst case scenario with your logarithms is dealing with these kind of like fractional exponents. So in this case, we are still going to kind of do the base to the exponent. So like the 9 to the x. And I'm going to write this as a fractional exponent. So instead of saying 81 to the 5th root or 5th root of 81, I'm going to say that this is 81 to the 1/5. And I'm going to call this 9 to the x equals to 9 squared. So 81 is 9 squared to the 1/5. So this is 9 to the x equals to 9 to the 2/5. And then we could just say that x is equal to 2/5. So when you're doing your delta math, if it is not immediately coming to you, I would encourage you to copy down a few examples that are already done, and then just kind of look for patterns like how we always use the base and how the number that we're looking for is always the exponent.